Zebra and quagga mussels are one of the first big invaders to the Great Lakes ecosystem. They were brought into the Great Lakes in the 1980s via ship's ballast water from Europe, and they're small fingernail-sized mussels, but they create dense colonies, so they create problems for water infrastructure. They clog water intake pipes, they can colonize docks and boats and other equipment. They've also dramatically changed the ecosystem and the food web dynamics that affect our valuable sport and commercial fisheries.
With so much at stake, a collection of researchers, resource managers, environmental engineers, industry representatives, as well as state and federal agencies joined forces to form the Invasive Mussel Collaborative with one hope.
If this group of diverse managers and researchers from different agencies and different institutions and stakeholders and affected industries could get together as a collaborative, we could work together and leverage each other's resources and expertise in order to move solutions forward to managing zebra and quagga mussels.
The collaborative has been conducting research at Good Harbor Reef in Lake Michigan, just off of Sleeping Bear Dunes National Lakeshore. Known mainly for its massive sand dunes left behind by glacial migration, what is lesser known are some of the issues that have been brewing under the waves.
Sleeping Bear Dunes National Lakeshore was actually voted the most beautiful place in America by Good Morning America.
Good Harbor Reef is a reef that's right off of that. It's a fairly significant reproductive area for lake trout and lake whitefish.
It's also close to Leland, Michigan, which is well known for the Great Lakes fishery. And the mussels have really just covered that reef.
When mussels cover a reef, they can choke critical spawning habitat used by native fish.
The Great Lakes fisheries generate right around $7 billion annually. Recreational fisheries, commercial fisheries, as well as tribal. So it's a very significant economic engine for the region.
Invasive mussels impact the environment by literally sucking the life out of the water, depriving it of nutrients at the bottom of the food chain relied upon by native fish populations.
Right now with lake whitefish, we've seen a fairly significant decline in abundance as well as the yield of those species.
The mussels can also give rise to harmful algae.
As the zebra mussels and quagga mussels came in and ate all of the plankton and things up, they also left a lot of nutrients, and that nutrient served as fertilizer for Cladophora algae, which produces toxin. Aquatic insects eat it, fish eat the insects, and then birds eat those fish. We had a large avian botulism die-off. So we started doing some long-term studies trying to get a deep understanding of what invasive species impacts might be on our fisheries and reef systems.
The research in Good Harbor Bay grew out of conversations between researchers and resource managers who realized they could help each other.
The National Park Service mentioned that they had been doing experimental mussel removal, sending divers down to the bottom of the lake to actually scrape the mussels off. They were also establishing a good baseline understanding of what the local ecosystem was like. So if a treatment was implemented, you could not only look at what the effects of those treatments were on the mussels, but also understand how it might change the ecosystem.
We had a site with ecological data and a need for a larger treatment, and they had a larger treatment and a need for an ecological site.
Limnotech is an environmental engineering firm that helps solve problems in lakes and rivers.
The Invasive Mussel Collaborative presented us with some options that they had in mind. We basically selected as a team the most effective one, which we thought was the Zequinox treatment.
Zequinox is an EPA-approved treatment that kills zebra and quagga mussels with no known impacts on other aquatic organisms.
The ideal aspects of the Zequinox are that it's target specific. It only affects quagga and zebra mussels.
Prior to Zequinox, there were a couple of tools that could be used in open water environments, but they were highly toxic to other organisms.
We're trying to minimize the amount of product that's being used in the open waters.
But how do you apply Zequinox to a reef at the bottom of a lake and keep it from just floating away?
So we set up this array of tarp systems that were basically framed underneath the water, and then we worked with the divers to develop a way to actually use a wand to pump from the boat down through the wand and spread that out.
So this is a really unique application, and we're really curious to see how effective it is.
You can clearly see in photos of the reef immediately after treatment that all of the algae that was there before covering the mussel beds is now gone, and there were just empty shells, essentially.
A dive team from the University of Wisconsin-Milwaukee, led by Harvey Bootsma, observed a mortality rate of around 95% in areas treated with Zequinox.
We've been monitoring this site over time, looking at what's happening to the quagga mussels, what's happening to the nuisance algae, what are the numbers of round gobies down there, how are they being affected when we remove mussels from this area. And we actually are seeing evidence that there is less nuisance algae growing where we've removed these mussels.
It uncovered a lot of the substrate that are used by the fishes for reproduction. Those were completely encrusted by the invasive mussels.
This approach doesn't mean that we can get the invasive mussels out of the Great Lakes, but it holds promise for controlling mussels in small sites like critical reef habitats that native fish depend on, and at water intakes at power plants or water treatment facilities.
I end up being hopeful given the passion and the progress that we've been making.
Good Harbor Reef was a great laboratory, essentially, to start with, and we already had a good foundational knowledge and partners in place that could help us implement this project. So we're going to be looking for what the next set of tools are that we want to test and what the next set of locations are that we want to look at. The problem of zebra and quagga mussels in the Great Lakes region is a complex problem, and it's a large problem. But we do have expertise and resources and knowledge, and if we work together and leverage each other's expertise, I think we can be successful.